right, kids. What we are going to do is we are going to go over the information in topic 1.9, which is using expressions to describe patterns, okay? We've already learned about expressions, writing expressions, how to evaluate expressions, and now we're going to use expressions to describe patterns, okay? You're going to want to pause the video, take out your notebook, and open up to topic 1.9, using expressions to describe patterns, okay? So pause the video, get yourself set up. All right, here we go, kids. One of the things that I would like to add to what is in the book is that finding area is a pattern, okay? And the expression for finding area is length times width. So what that means basically is that no matter what rectangle you have, or square, you can multiply the length, 5 inches, times the width, which could be 10 inches, and you would come up with the area of 50 square inches. Now, this certainly applies to that rectangle, but it would also apply to that rectangle, or that rectangle, okay? So over time, mathematicians developed this expression to describe the pattern of length times width to get area. So if somebody says, hey, what pattern do I use to find area? They would say, well, you multiply the length times the width. And that's how we see the value of patterns in the real world. All right? So then we have another famous one, which would be volume. Okay, volume is the same type of pattern in the sense that the pattern gave rise to the expression length times width times height. So in other words, if you have a length of 3, let me get rid of that. If you have a length of 3 centimeters and you have a width of 2 centimeters and a height of 4 centimeters, we know that if we multiply the length 3 times the width 2 times the height 4, we would get the volume of 6 times 4 would be 24. So we would have 24 cubic centimeters, okay? So we realized over time that this pattern of multiplying length times width times height gave rise to volume. All right? And so that's what we're talking about, is finding patterns and then writing expressions so that we can apply those expressions to many different but very similar experiences. Okay? So let's take a look at what we have in the book, using expressions to describe patterns. It tells us, how can you write expressions to describe patterns? They give us an input-output table. Delvin saves a part of everything he earns. He's a good kid. He's saving part of everything he earns. The table at the right shows Delvin's savings pattern. So his input is how much he earns, and the output is what he has saved. Okay? So the input column shows the money he's earned, and the output shows the money he has saved. We have an X and we have a Y. When this happens, it leads to this, okay? Write an expression to describe the pattern. So there's a pattern that takes him from here to here. There's some type of operation going on that is the pattern that takes him from here to here to here. Okay, so there's something going on there. We want to figure out how we go from the input to the output. Excuse me. An input-output table is a table that relates values. Again, this value relates to that value through an expression. Identify the pattern. Well, in this pattern, it's the easiest thing to identify is we have a number that decreases, a number that decreases. And if we look at it, we go from 84 to 42, 66 to 33, 50 to 25, 22 to 11, 30 to 15. And so once we get down here, it's like, oh yeah. 15 is half of 30. 25 is half of 50. Now I see a pattern. So what is the relationship between the values? Well, in this case, we would say that 84 can be decreased or divided by 2 to get 42. Or we could use multiplication by 1/2. So 1/2 of 84, because we're multiplying a half times 84, is 42. 1/2 of 66 is 33. 1/2 of 55, or 1/2 times 55, is 25. Alright? So that's how we come up with our pattern. So the pattern is 1/2 of the input equals the output. 1/2 of 84 is 42. 1/2 of 66 is 33. 1/2 of 50 is 25. And so if you wanted to test that, you could easily say, okay, 1/2 of 22, and multiply 22 by 1/2. And that was how you come up with your answer. One way to make this easier is to write 1/2 as 0.5. And so if you multiplied 0.5 times 22, you would see that you would get 11. Okay? Now, you might want to stop right here and go watch the Fox video. If we're in class, we're probably going to stop and do some Nearpod at this point. Okay? Now, if you're doing this on your own, we're going to do a couple practice problems. It is important for you now to stop the video and try to actually answer these questions, okay? If you can't answer them, you try, start the video back up and see what the explanation is. Remember that when you're doing these problems, that most of your brain power, we know from research and MRIs of people doing math, that you're going to go through 4 stages. Stage 1 is where you're just looking at the problem. A lot of brain power, a lot of brain activity. Stage 2 is you plan to solve it. A lot of brain activity, The final step, or stage 3, is computation, and there's not as much brain power going on there because it's just rote memorization of doing math. And then stage 4 is checking it. There's not a lot of brain power there either, but those are still 2 very important steps that require accuracy. But remember, really look at what you're doing before you do it. Okay, so anyways, why don't you see if you can answer this question? It says, use this table for 6 and 7. Here is the table. Take a look at the table. What does it tell you? What relationships do you see? What patterns do you see? Okay, so pause the video and answer number 6. What is the cost of 4 pounds, 5 pounds, 10 pounds of apples? I would recommend actually copying the table down and filling it in. That's part of step 1 and 2. Alright, pause the video and give it a try. Okay, let's see how we did. Well, in this case, we can see that if we have the apple weight of 1 pound, 1 pound costs $2. So that's kind of like a unit rate. Unit rate is $2 per pound. So then we say, well, if you get 2 pounds, it's going to cost $4. If you get 3 pounds, it's going to cost $6. So obviously, in this situation, we have a pattern where you're multiplying by 2, okay? So here's the situation. 4 pounds will cost $8. 5 pounds will cost $10. 10 pounds will cost $20. Okay? So you can kind of see what the relationship is. So now for number 7, write an algebraic expression that describes the output pattern if the input pattern is variable A. So they're telling you they want you to use A as the variable when you write your algebraic expression. Pause the video and see if you can write that algebraic expression. Alrighty, how do you do? Well, in this case, you probably realize that you're going to take 2 and multiply the weight of the apples, okay? So you multiply the weight of the apples by 2 to get the output, the price. Okay, so the output, in order to get the output, you multiply the input by 2. Okay, and the input is A for apples. Alright, that's the variable. Let's try these ones. Alright, here they give you another table. Again, I emphasize that you should copy tables down if you're doing something like this. Alright, number 8, copy and complete the table. They tell you to do that. Pause the video and see if you can fill in these missing amounts. Alright, let's see how you did. Okay, so we have a total number of students, and then we have the number of study groups. Okay, we can see that the number goes down. From the input to the output, it goes down from 18 to 6, from 24 to 8, 27. You know, these look like they're related in terms of multiples or factors somehow, like there's maybe some division going on there or something. All right, so anyways, number 12, the correct answer is 4. How do you go from 12 to 4? Probably through division. 12 divided by 3 is 4, 18 divided by 3 is 6, 24 divided by, this looks like a pattern. 27 divided by 3 is 9, 36 divided by 3 is 12, 39 divided by 3 is 13. So our expression must involve division, okay? So write an algebraic expression that describes the relationship between the input and the output. Pause the video and write your expression now. Alright, let's see how you did. Well, in this case, the mathematicians say that you're going to have x divided by 3. Okay? So x, being the total number of students, divided by 3 gives you the number of study groups. Alright? Okay. If you need to review, you can always back the video up. Remember, you can back the video up if you don't understand something. Alright. Here are some pretty tough looking problems. Why don't you see if you can solve number 10. Pause the video and see how you do. Alright, here we go. Let's take a look at this. Use the input-output table at the right for 10 and 11. Okay, so our input and our output, okay? And they're showing that there's a relationship, but it's not jumping out at me right away. I do know that we're decreasing, definitely, and it looks like we're decreasing by twice as much, but that's a 5. Let's see what we have here. Hazim keeps 1/3 of, that's a clue. The word of means multiplying a lot of times. Keeps 1/3 of the tips he earns. Also, he gets $1 each night to reimburse his parking fee. So it's almost like it's a two-step operation going on here. This information is shown in the input-output table. Write an algebraic expression that describes the output pattern if the input pattern is the variable k. Alright, well, in this case, they want us to write an algebraic expression. Well, we're going from 12 to 5. And then we're gaining $1 there, okay, because he gets $1 a night, gets a reimbursement. So what we have is 1/3 of the tips he earns. So these are the tips he earns, so it would be $12, and we would get 1/3 of $12. So if you set it up and do it, it looks like this, 1/3 of 12. Now to refresh your memory on multiplying fractions, all you do is turn 12 into an improper fraction. 12 over 1. And then you multiply across. Now you could cross simplify, but you can just multiply 12. 1 times 12 is 12. 1 times 3 is 3. 3 into 12 will go 4 times. So that tells me how much he earns from his tips. That's how much he keeps from his tips. But if we go back up to the table, that's not, he should only have $4 here, but he has 5. And that's because he gets $1 each night extra reimbursed for parking. Okay? So then what we see is we have that $4 plus the $1 gives us 5. So in other words, 12, 1/3 of 12 equals $4. Add a dollar to that and you get 5. So our expression is this: k, the variable, divided by 3 plus 1 would give you this. So 12 divided by 3 is 4, plus 1 is 5. Or you can do it like we did it, and you can say that 1/3 of k is 4 plus the 1 equals 5. So in this case, 27, 1/3 of 27, or 27 divided by 3 is 9, plus 1 is 10. So that helps us answer number 11. And if you want to pause the video and answer number 11, you can do that now. Oh, my shoulder kind of gave you the answer, didn't it? If you didn't pause right away. So 1/3 of 36. 1/3 of 36, you set it up. 36 is an improper fraction. Or you could just simply divide by 3. Okay? Dividing by 3 would give you 12. Multiplying by 1/3. 1 times 36 is 36. 3 times 1 is 3. 36 divided by 3, because this is a division expression, 36 divided by 3 is 12. Now remember, we have to add 1. Whether we're dividing by 3 or multiplying by 1/3, we have to add that 1 for the parking reimbursement. So 12 plus 1 is 13. So our answer should be 13. Okay? Alrighty, well, if you have any questions with this, you can see your parents for help if you're at home trying to figure this out. If you're at school, you can come see your teacher. Alright? You did a nice job.